2 bar
Tak dengar. Sekejap. Tak, line tak bagus. Sekejap. Okey, cuba.
2 bar, each materials of a different material are connected and placed between two walls when the temperature is T1 equals to 100 degrees Celsius. Determine the force exerted on the rigid support when the temperature becomes T2 equals 20 degrees Celsius. The material properties and cross-sectional area of each bar are given in the figure Q10.
Yes, we have two materials, solid bar. One is steel. This is the properties for steel. And this is brass, tembaga. And this is the properties for brass. Okay. So what is the force acting on the support? Okay. Alright. Initial T is 10, increase to 20. So delta T is only 10. First, so this is increase. So we need to release the support and allow it to elongate. And now you press it back with RB. So calculate the PL over AE, PL over LE according to these materials. And you equate delta T and delta R. So you will get RB. Dapat? For this example, the structures consist of two materials, different materials. So you must calculate, alright, 9.67. Okay, correct. For these structures, the material consists two different materials. One is steel, one is brass. So release one support at the B. So we allow it to elongate. For steel, how much it will elongate alpha delta TL. So he will elongate for 0.036. While the brass will elongate according to their properties is alpha delta TL is 0.063. And we apply RB on the right, point push back to the original position, amount RB, balance it, so we have RB on the far end. When you put RB here, you must eliminate that RB, put on the left, and it must be balanced with the right. Okay, so every members will receive RB. So the total elongate for RB is 0.01417 RB. We know that this is very solid connections. We not allow any deformation happen. So delta R equal to delta T. So RB is 7. Dah? Dah? Tolong seorang jawab dah.
Dah.
Okey. Okey, sekarang kita tengok material yang parallel. Okey, nampak work example 25? Nampak?
Nampak doktor.
Okey, saya nak bagi tahu kita ada test satu saya punya syllabus. Okey, test satu adalah 11. Hari bulan 11. Pukul 11 pagi. Okey. Hari Sabtu kita punya kelas hari Rabu pukul 11 ayah. Okey, test 1 adalah 11 hari bulan 11. Okey. Pukul 11, 1 jam. 1 hour ni. Okay. What's the topic cover from day 1 until next Wednesday on 4th? Okay. So what is the topic on Wednesday? You wait until we meet on the... Okay, how many questions according to this topic? Alright. According to what topic we cover, okay, within 1 hour. Study semua, nanti ada cukup 1 jam boleh jawab. Okay. So, started from day 1, example 1 until today we'll finish at example 25 and tutorial. Okay. Today is the last lecture. Habis. Okay. So today lectures will finish until example 25 and also tutorial. Alright. Plus one topic on Wednesday. Okay. So there's will no lecture on 9. Satu minggu. Saya bagi 1 minggu untuk study. There will be no lecture on 9. So study from Wednesday until Wednesday. Any questions? Ada soalan? Boleh saya teruskan? Okay, the figure shows one copper rod with 30 millimeter diameter tightened by 2 steel rod 20 millimeter diameter. So this is your rod. So we have another small rod. Okay. So the figure shows one copper rod with 30 millimeter diameter. So this is 30. Right. And tightened with 2 steel bolt 20 millimeter. So this one is 20. 20. No changes was observed at temperature 20. Calculate the stress in copper and steel at temperature 70. So since the temperature is increasing, so we allow the deformation. Okay, allow the deformation due to alpha delta TL. Okay, so the deformation for copper, is 0.2930. The deformation for steel is 0.155. Okay, remember, in this situation, we not allow them to elongate separately like this. Okay, all right, we not elongate, allow them to separate like this. So what we do is we have one line. Okay, final line. This is the final line, meaning how much force you must apply so that the steel will add more elongation until here. Okay, and how much you must apply so that the copper will shorten until here. All right, so we not allow this happen separately. Okay, we must have one datum, final datum. Yang pendek kita panjangkan, yang panjang kita pendekkan pada satu garisan. So you need delta R external load, this amount. You apply delta R and you need this amount to elongate until the final line. And you need this copper R to press so that the green will stop at the final line. Okay. So this is delta R. You need R to pull it to this line, and this is R copper. You need this copper to shorten to this line. So temperature already calculated. Now calculated for external force. So the external force for steel, we need this amount 0.775 10 power of negative 3 R steel. And we need this amount R delta copper so that it was shortening. Okay. So final length is delta T plus delta R. And the second equation is delta copper due to temperature minus delta R external force for copper. And we have the third equation, which is we call equilibrium equation. Forces pointed left must equal pointed right. So if the left is R, the right is 2R still. Okay, in order to have equilibrium, right? In order to make equilibrium, forces acting to the left must equal acting to the right. So left is negative, left is R copper, right is 2R steel. Okay. So we make the equation 1 and equation 2 and replace one forces, either copper or steel, and we'll get steel. After that, put it back to the copper. All right. So calculate the stress, divide by area. Okay, boleh tolong baca? Nampak soalan 11?
Tak nampak tu.
Oh, okay, okay, sorry. Baca seorang.
The rigid bar shown in figure Q11 is fixed to the top of the three posts made of steel and aluminium.
Post is column, eh?
The posts each have a length of 250 mm when no load is applied to the bar and the temperature is T1 equal 20 degrees Celsius. Determine the force supported by each post if the bar is subjected to a uniform distribution load of 150 kN per meter and the temperature is raised to T2 equal to 80 degrees Celsius.
Okay. All right, you can try these questions. Okay, this is the steps. First, calculate the deformation due to temperature. And 2 is due to forces. Try to shortening back. The temperature tries to increase, but the force tries to decrease. So you must have the equation. The temperature tries to increase, the force tries to decrease. Try to make the elements shortening. So it will stop in one line. Okay, so today's finish with this first topic. Okay, saya habis awal hari ni 12.30 sebab topik kita dah habis. Okay, so topik hari Rabu adalah shear force bending moment. So kita punya test cover sampai topik hari Rabu. Apakah topik dia, nanti awak tunggu hari Rabu. Ada soalan? Tadi saya ada bagi jawapan Ada soalan? So kena buat semua balik contoh 1 sampai contoh 25. You must study all chapters. How many soalan is depend on me. Don't worry, what topic will cover from the day 1 until Wednesday until Wednesday, this Wednesday until 4 November. So this is your first test. Ada soalan?